Hello, I'm Eric Snodgrass, and thank you for watching today's Ag Forecast brought to you by Nutrien Ag Solutions, your premier platform for real-time global insights. Well, after an historic season here in the North Atlantic with tropical cyclones where we had 30 named systems, the attention now shifts south of the equator. And what I want to show you here was yesterday in the southwestern part of the Pacific Ocean, a powerful tropical cyclone named Yasa that was heading toward Fiji right in through here. As it was going in that direction, wind speeds in here were gusting over 165 knots, which would put this at Category 5 in strength. And overnight last night, it bear down on the islands, and we're going to see later today just how much damage was done. Just something neat to note here, we are south of the equator, so this system, which is a deep low pressure system, is spinning clockwise, which would be the opposite direction in the northern hemisphere. And that all has to do with the Coriolis effect, which is to the left in the southern hemisphere. So as the pressure gradient pulls the air into the center before it rises, you end up getting a leftward turn in the winds, and that's why it circulates in this direction. Now in the northern hemisphere, they go the opposite direction. We have two large low-pressure systems right now bearing down on North America. One on the west coast, pushing inward, bringing a lot of snow and precipitation to the west coast, and then a big nor'easter. Now I want to talk about that nor'easter because you probably heard a lot lately about how much snow is expected out of this. And what I want to talk to you about is what are called snow-to-liquid ratios. Now, if you don't want to learn about it, just fast forward and you can get to the next part, but I thought you might find this interesting. So when we use numerical weather prediction, like our models, the GFS or the European, to predict precipitation, remember that what the model ultimately does is it predicts liquid equivalent, how much total liquid can be precipitated out. The model then uses a microphysical scheme to predict precipitation type, snow or sleet, freezing rain, or rain. Now, one of the complications of forecasting snow is that a typical snow-to-liquid ratio is 10 to 1. And therefore, any tiny change in the total amount of liquid predicted to be precipitated out manifests itself in a 10x change, a 10x multiplier on snow depth. Now, where do we get that 10 to 1 ratio? Well, mostly it was empirically derived, which means through experiment. We just measured and found that generally we were getting about 10 inches of snow out of every 1 inch of rainfall. But that's not a constant. And that liquid to snow ratio depends on several things. And I just listed a few here. For example, the temperature of the atmosphere, where the snow is formed, deep, thousands of feet above our head, is very important. It's important because it determines what type of ice crystals are generated. Now, I pulled this out of an article several years ago, and this was actually from my notes when I used to teach at the University of Illinois. But what it shows, and this is common in almost every microphysics textbook, is how with decreasing temperature and increasing supersaturation, we get different species or habits or types of ice crystals. And what's important here is how these ice crystals fall, how they interlock, how they aggregate, and how much distance there is or space between each ice crystal as they fall. Now, what's happened is that multiple places across the United States and across the world have been taking these measurements, where they're looking at the effect of temperature, for example, here in Boulder, Colorado, and the ratio, how much snow was achieved out of the liquid equivalent. And what you find in most situations is that that value peaks somewhere around a 10 to 1 ratio. But notice, the colder you get, so let's start here at freezing, the colder you get, the higher the ratio becomes. And as a result, sometimes places like those Alberta Clippers that run across the northern tier of the U.S., or when the snow goes over the Cascade Mountains or the Sierra Nevada, you can get liquid to snow ratios that are 20 and even times 30 to 35 to 1. And therefore, that's a very light and fluffy snow that you can just blow away. But if the ground temperature is warm, or if the temperature profile at which it falls warms quickly, you get a lot of aggregation, some melting, some compaction, and that can really change the value of the depth of the snow at the surface. Now from there, what I want to talk to you about is snowfall rates, because generally they're dependent on how strong the front building mechanisms are. In other words, how quickly or how easily we're squeezing together the warm and cold air, and the possibility of having convection. Now, the big system that's going up the East Coast right now, this one right here, does not have much embedded convection. We're not seeing any lightning as an example in here. But look at the flow of the atmosphere early this morning. We have this massive, what we call warm conveyor belt, transporting moisture out of the Gulf of Mexico across Florida. It's then getting wrapped into this deep low pressure system. And there's a band right in through here of very strong mid-level frontogenesis. That's the creation of a front. And over that air is rising rapidly, and that's where we saw our greatest snowfall rates in Pennsylvania and New York. What's making this all possible is also this large high-pressure cell to the north, keeping that cold air near the surface, giving us those relatively high liquid-to-snow ratios. Well, here's the other low that's coming into the Pacific Northwest, bringing precipitation there and into California. Desperately needed rainfall now coming pretty far south here over San Francisco Bay. But in the middle of the country, look at the way the flow is going across from the northwest to the southeast. And we have relatively dry conditions here for a while. We're going to talk about that here in a few moments. But you'll see here as I animate last night's radar animation to early this morning, watch this tight band form right there. See it? And along that band, there have been some reports in Pennsylvania of well over 30 inches. And early this morning in parts of New York, the snowfall rates were ranging between 2 and up to 6 inches of snow an hour. This is a powerful nor'easter, and we're going to have to wait till later today to see the total snowfall amounts out of it. So I don't have any of those to share with you. But just take a note, along the west coast, the frontal rain band that's coming all the way down here, look at this, into California, bringing in some much needed moisture pretty far to the south. Okay, let's see where things are going, and we're just going to watch a little bit of last night, and we'll pause it right here early this morning. So this is valid 6 a.m. Central Time. So notice how quickly this system is moving on off the East Coast. So we're going to still continue to see some light snow showers over in parts of Michigan and Ohio, with the heaviest snow bands exiting New York, coming up here into Vermont and New Hampshire, and eventually out into parts of Maine. So watch as we go from early this morning through about midday. Now, after this, you're going to see in a few moments that our low-pressure track is going to favor Canada. And there's a low that's developing there. You can actually see the front right here. You see the front that went slamming into British Columbia, moved over the Northern Rockies, and is now, it's off my screen here, but it's moving through this part of Saskatchewan and Manitoba. We're going to watch out later tonight for right along this area to possibly get some mixed precip, so possibly some freezing rain with snow once you get back into Wyoming to Utah. But as this plays forward, let's go through the evening hours tonight into the early morning hours. So right along that front, you're going to see here some light snow, brief light snow, possibly a mixture into this part of South Dakota. And as it goes on from there, well, let's watch how it spreads a bit farther to the east here as that low wraps itself up in the Hudson Bay. We're going to get some snow pretty far to the north here in Minnesota, Wisconsin, into the UP of Michigan. And then by the time we get into Saturday morning, some scattered showers that are going to come down through parts of Texas into Arkansas and Oklahoma, with some light snow in this region right in through here. That's what we've got going on in the near term. Now, to explain to you where this is going to go after that, I want you just to quickly look at the bullet points over here on the left. We have a negative Arctic oscillation. It's right here. This high pressure cell, not only in the low levels of the atmosphere, but also in the mid levels here, right over the Arctic. That favors a lot of cooler air and more troughs that sink into the east and southeast. I'll show you that in a moment. Overall, the atmosphere is open for business. It's moving. It's not blocked. There's no massive ridges that are setting up over like Alaska or Greenland. But the problem is we're not able to really transport and then leave cold air across the lower 48. I'm talking much below normal temperatures. The polar stratospheric vortex is relatively strong at this point and not connected with the troposphere. And these last two things I'll show you in a few moments, but the MJO is not in the cold phases for bringing in deep, settled cold air across the lower 48. And without that strong subtropical jet stream piece coming from Hawaii to California, despite the better precip north, we're not going to get it south. Now, here's what I want you to watch. You can see the troughing already in place here around this big ridge. I'm just going to play this, and I want you to see how each of the systems cuts through here. Okay, cuts through this part of Canada. Ready? Here we go. See them slicing through there? I will pause it once we get out here and just show you that there is a trough I'm interested in right here, because this is early in the morning on Christmas Eve. And that trough, as it sweeps through, will be bringing in some very unsettled weather for this kind of eastern third of North America. But on the back side of it, outside of this trough sweeping through this part of Canada, this is not good flow to be bringing in precipitation on Christmas. And so we'll watch that very carefully. But you just saw how the systems crank through this part of Canada, and I'd like to show you that now by going to the operational European model. So here's our nor'easter. Here's the frontal boundary that's sliding into the western part of the United States, bringing in that precip pretty far to the south. Not getting fully into the San Joaquin Valley, but here it is. As we play this forward, let's now get to Saturday. So actually, this is Friday night. Here's that low. See it? So right along here, there's a frontal boundary. And along that frontal boundary, we're going to get some precip. And here we are Saturday morning with the scattered showers that are south and snow over parts of Michigan. Now from there, notice that the next low skirts right through parts of, Saskatchewan, Manitoba. We have this northerly storm track. And Therefore, the lingering fronts through here are not strong. They're just not, there's not a bunch of cold air behind him. In fact, there's quite a bit of mild Pacific air moving across the United States. Taking out to Monday, another weak low races here across parts of Michigan, northern Wisconsin, and Minnesota, so right in through this area. We have some scattered showers over the southeast. Another system then on Tuesday comes into the Pacific Northwest, bringing snow to the northern Rockies. But as we play this forward, what we do see is that getting out here to Tuesday night on the 22nd, getting into the 23rd, there is a low that is forming here. That's that trough I mentioned watching for the 24th. And you see that initially there's quite a bit of moisture on the north side of it here, bringing in some snow into this here. I'll show you the total amounts in a moment. But as it slides to the east, this is the 23rd, Wednesday the 23rd in the morning, afternoon, and evening. Here we go. This is the boundary that I'm going to be watching for some snow and some rain to develop. Because as we then get into Christmas Eve here, you see that parts of the eastern Corn Belt, getting down to Tennessee, Kentucky, currently in the forecast, are seeing some snow. Now, this is actually showing up in the ensembles as well. So we're going to have to just watch this carefully, and I'll give you several more updates before we see if this big nor'easter shows up once again here. But we're pretty far out in the forecast. We better not put too much stock in that. But I do want to show you that starting today at morning and going over the next 7 days, there's a few places that are quite dry, like in the center part of the U.S. Got some snow through here and a snow track up here. I'll show you the snow in a few moments. But this is the system that's coming through on the 23rd and 24th. So until then, it's dry in through this area, relatively dry through this area. Down here, we got a little bit of precip over the weekend, but dry, all right? Here in the Pacific Northwest, still got more precip coming through, but with no strong subtropical jet, California stays drier. And here's the problem with that. This map just looks over the last month at precipitation ranks, 128 years in this data set. Look at how dry it's been across the northern interior of the U.S. Dry in the northwest, dry in the southwest, and things have been much more active lately here. But overall, we don't see over the last month a lot of places that have been overly wet across the lower 48. Yeah, we've had some big snows in this area, and of course the nor'easter, but outside of that, not a whole lot going on. How much additional snow are we going to be adding? Well, these folks in here are increasing their chances of getting a white Christmas. And then you can see here the snow path coming in through here, coming into the northern parts of Wisconsin, Michigan, and Minnesota, and also the snow track that's going to be in this part of Canada, north about Highway 16. We can also see the bigger amounts we're expecting here in the Pacific Northwest. But getting out here past Christmas, just take a look at this pattern. It's relatively high in amplitude, but the flow shows me that these troughs are not necessarily anchored to deep cold air sitting here. And as a result of that, I see quite a bit of mild air moving into the U.S. And because of that, well, just go back to it. See how the ridge is building in here? Overall, look at the pattern in precipitation. It's just favoring drier conditions out into week 2. Now, when I tell you the pattern is mild, look over here at the graphic that's on the left. For Kansas City, Missouri, right in here, I did a trajectory tracing to show you that the air, watch in red, is really generally coming from the Pacific. It's not coming from here or here, bringing in the brutally cold air. And then we can also do the same analysis for this part of California. You see, when you get down here into Southern California in the San Joaquin Valley, we once again see that the flow is coming in this direction. Maybe I shouldn't draw that in blue and I should draw it in red. And the problem is it's not coming, watch in blue now, from there, which is what will be transporting a lot of moisture. We've been talking a lot about this as of late. You see, these trajectory models help us understand the source region of that moisture. And looking out into week 2, we do favor a slight dry bias across much of the U.S., with the flow coming in like this into British Columbia. Now watch what it does to the temperatures. Here's Thursday's max temperatures compared to normal. We see the above average temperatures here across the northern plains, but behind that nor'easter quite cool. Playing this forward, what we've got now going into Friday and Saturday, again, we stay relatively mild for this time of year in this region. Going from there into the weekend, so here's Sunday. Gosh, I mean, the models are really favoring much above average temperatures here on strong southerly winds on Sunday. But then pulling through the rest of the weekend, you see there's Monday's high temperatures compared to normal, getting into Tuesday and Wednesday. Now remember, it was after Wednesday that we saw the next system come through here and our better chances for snow in the eastern Corn Belt. We'll watch for that, okay? But at this point, a mild kind of lead up here with that Pacific air going out to the week of Christmas. Looking at our temperatures, day 5 through 10, you can really see it, okay, in both the models here. Let's draw that in black over here on the GFS. The coldest air is tucked away in this region. And as I go out here to day 10 through 15, both the models continue to show more favorable, I guess, mild conditions, but with that negative AO maybe favoring a bit cooler here over the southeast, which will be characteristic of that. Now, what's going on with the polar vortex? Well, it's meandering quite a bit, but it's keeping its act together. No major displacements, at least through the end of the year, that could give us a major change in that temperature pattern. But I'll be honest, getting out here toward the end of the year seems to be a major buildup of heights here, indicating some warming with a major drop-off over here in Europe. And so we could be looking at a January disruption in the polar vortex, which could give us a much more different temperature pattern then. But where I want to finish today, I actually covered a bit in yesterday's long range. We have quite a few more people that watch our Monday and Thursday content, so I'm going to review it. But if you watched the video yesterday, you can go ahead and shut her down here. You see, talking about the tropics, the MJO continues to favor phases 5 and 6, at least through the end of the year. And historically, that's correlated with warmer conditions here, with colder air getting tucked into this part of Canada back toward Alaska, which we saw. The MJO is not well forecast at this point to come out through phase 7, 8, 1, and 2, which, as you can see, going to phase 7 and 8 really let that cold air out across the U.S. So this is consistent with the temperature patterns we saw through the end of the year. Now, speaking about what's going on with the MJO, I want to talk about South America. So we know that in Brazil's state of Mato Grosso, right here, you can really see in that soil moisture map that as of late, it's been quite dry in southern Mato Grosso do Sul, Paraná, and Rio Grande do Sul, some drier pockets there. But keeping an eye right here on Mato Grosso, do notice this. Here's the late arrival of the monsoon. Here's the precip that allowed them to plant quickly in October. Early November, dryness caused some replant, a long stretch of dry days here at the end of November, about 12 of them, some decent rains that followed, and then a dry last 4 or 5 days. You see, it's going to continue to be dry for the next 5 days in this area, with the precipitation returning toward normal after the weekend. But that same area, not only through the end of the year, but then getting into January, we anticipate staying wet. And we're now going to start to be discussing, because the model's been quite consistent with this, drier conditions in southern Brazil and Argentina. And throughout the month of January, I'm concerned about that, given what's going on with our La Nina. Our La Nina is making its last big push with trade winds here across the central Pacific. And we're starting to see some warming over here off the west coast of South America. And thinking about our analog years, it's very common that once you get here, this is week 52, so that'd be the end of the year, that we start to see those temperatures go back up, which means we're going to go away from the cooling effect of La Nina and start to see the temperatures recovering. Now, here's some of the analysis I worked on. Using those analog years, we tended to see normal monsoonal rains in through this area. All right, so from Paraná, Mato Grosso do Sul, and Mato Grosso, Rio Grande do Sul down here, and Argentina could be on the drier side of things as we look forward in this forecast. Now, the models looking at January, February, March are keeping this area a bit wetter, drier to the north and drier to the south. My concern is going to shift to what's going on in Argentina, I think, moving forward. But a lot of damage has been done to pockets of Brazil's northern and central growing regions recently. Keeping with this theme, what about North America? So remember, the change here, going back toward INSO-neutral conditions. Well, I went and used those years, and only looking at my La Nina analogs, we tended to have an active Ohio River Valley storm track, which really started back here in the Ozarks, but cut through the Ohio River Valley. And we did seem to get quite a bit of precipitation along Pacific Northwest into Northern California. What I don't like about these analog years is how dry the southern plains were, how dry it was in the southwest and along the southeast, because that is the region we're going to be watching drought for the next several months to see if by spring it has spread. And that's a common discussion point we've had here as of late. I do want to just reiterate that got some brand new model data here. So you've already seen this one. This is from the European, favoring that same Ohio River Valley storm track and the wetter conditions in the northwest. Drier along the south. The latest NMME echoes that same forecast. You can see it here. But here's the newest stuff I'd like to share with you. When we think about what the temperature pattern may be, it looks as though once we get past what we've got now, which is that mild Pacific air, we could favor more cold air intrusions coming out of the northwest with warmer conditions south. And then I'll also show you this. This is the brand new data from the IRI multi-model group. Coolest air in through here, warm along the southern tier of the U.S., and that's where they got it dry too. So I just want to kind of complete that story for us today and kind of echo some of my thoughts from yesterday. I appreciate your attention this week. Hope you all have a great weekend, and I'll talk to you next Monday. Thanks.